Hello, Jemason Exam Tuition. In this session, we focus on vectors, and we're going to be looking at scalar product of two vectors and how they can be applied in solving questions. Further in the video, I would be looking at the properties of scalar product and how they can also be applied in solving questions. If we have two vectors, A equals Bi plus Qj plus Rk and B equals L plus Mj plus Nk, the dot product or the scalar product of A and B is simply Pl plus Qm plus Rn, as simple as that. An example could be 3i plus j minus k dot 2i plus 4j minus 5k. This gives 3 into 2 plus 1 into 4 plus negative 1 into negative 5. This gives 6 plus 4 plus 5, which is 15. In particular, A dot B is defined in terms of the angle between the vectors as A magnitude, B magnitude, cos theta, where theta is the angle between vectors A and B. We must emphasize that the angle between two vectors is actually the angle between the vectors when they either diverge from their point of intersection or they converge to that point of intersection. So these are the two situations that can arise. In the exam already you can be asked, after having been given points, A for instance 3, 2, negative 1, B 2, 1, 3, and C 4, negative 1, 1. You can be asked to find the cosine of angle BAC. In order to find the cosine of angle BAC, I would have to simulate the situation as it would occur in the three-dimensional space. Angle BAC actually has vertex at A, so I will label A there, the middle letter, and then BC. So the angle is defined in such a way that there are displacement vectors binding it, which I can make them to diverge or to converge. So there are two situations you can use here. Either they are converging or they are diverging. So divergence would be better as a rule for you, so you could always get those displacement vectors by starting from the vertex as a rule. In that case, in order to find this angle, if I call it theta, I would need the displacement vectors AB and AC. So I get AB, which is supposed to be OB minus OA. And by direct subtraction, B minus A would give me 2 minus 3, which is negative 1, 1 minus 2, which is negative 1, and 3 minus minus 1, which is 4. Then there is AC, which is supposed to be OC minus OA. By direct subtraction again, I get 4 minus 3, which is 1, negative 1 minus 2, which is negative 3, and 1 minus minus 1, which is 2. So in order to get that angle, I start with the cosine of the angle. I use this property or this relationship that we had up here. I make cos theta the subject, then I should have A dot B over A magnitude B magnitude. But our vectors here being AB and AC, I will now say cos theta equals AB dot AC all over AB magnitude AC magnitude. And when I bring in my vectors, I get negative 1, negative 1, 4 dot 1, negative 3, 2 all over the magnitude of the first vector. I square the components and add, so I have 1 plus 1 plus 16. The magnitude of the second vector, I square the components and add again. I have 1 plus 9 plus 4. Okay, for the scalar product at the numerator, we have negative 1 times 1, which is negative 1, negative 1 times negative 3, which is positive 3, 4 times 2, which is positive 8, all over the root of 18 dot the root of 14. And this gives 10 at the numerator all over root 18 is the same as root 9 times root 2, so it gives 3 root 2 and then root 14. Overall we have 10 all over 3 root 2. I could simplify by breaking down root 14 into root 2 times root 7, and that gives root 2 times root 2 will be 2 and then times 3, so it gives 10 all over 3 times 2, 6 root 7, and therefore cos theta would be equal to 5 all over 3 root 7. You could proceed to rationalize the denominator to have 5 root 7 all over 3 times root 7, which simply gives 21. There are situations where they might require the cosine of the acute angle BAC. Then you simply get the absolute value at the end, possibly when the cosine will be negative. You could also have the sine being asked, the sine of the angle. So if it is sine theta that is asked, I will pass through this procedure and get cos theta, and then use the fact that sine theta would be equal to 1 minus cos squared theta. It can even be the tangent that is asked. Then you say tan theta equals the root of sec squared theta minus 1. All these are obtained from the Pythagorean identities. Now we have properties of scalar product, which are also very important in solving some problems. One of them would be the fact that A dot A is the same as the magnitude of A squared. The second one, we have that A dot B is the same as B dot A. So commutativity of scalar product. We have also A dot B plus C equals A dot B plus A dot C. This one is distributivity of scalar product. A common question that makes use of these properties is the fact that they can give you two vectors, b of magnitude 3 and q of magnitude 2, and then they ask you to find the magnitude of a linear combination of these two vectors. We could have something like 3a plus 2b magnitude, given either the angle between them is pi on 3, or even their dot product can be given in such a situation. So if I have to find the magnitude of 3a plus 2b after having been given the magnitude of the individual vectors, I would use this first property and then the second one. To start with, I would write 3a plus 2b squared. The square of the magnitude is equal to the dot product of the vector. This gives 3a dot 3a is 9a dot a plus 3a dot 2b should give 6a dot b, and then 2a dot 3a should give plus 6a dot b, and then 2b dot 2b should give plus 4b dot b. Then I would have 9a magnitude squared. Remember, a dot a equals a magnitude squared, plus 6a dot b plus 6a dot b gives us 12a dot b, plus 4b dot b is the same as 4b magnitude squared. I have 9a magnitude squared plus, where the dot product is given, then I just need to substitute negative 10 for a dot b and then I proceed. But where the angle is given, you would need again to use the formula for a dot b, which is a magnitude b magnitude cos theta, theta being pi over 3 in this case, plus 4b magnitude squared. So we are using the property that a dot b equals a magnitude b magnitude cos theta for this middle term. So now I'm left with substitution. 9 into a magnitude was, sorry, we're dealing with a and b instead at the end, sorry. So I use a magnitude being 3 and b magnitude being 2. So I would get a magnitude squared, which is 3 squared, plus 12 into the magnitude of a, which is 3, into the magnitude of b, which is 2, and cos pi on 3 cos 60, which is half, plus 4 into b magnitude squared, b magnitude being 2, so 2 squared. 9 times 9 gives 81, 2 cancels 2, and we have plus 36, plus 4 times 4, 2 squared, 4. 4 times 4 is 16. And so we have that 3a plus 2b magnitude should be equal to 133. That is the square of that. So 3a plus 2b magnitude should then be the square root of 133 units. That magnitude is the length of the vector, so it has arbitrary units. So if I instead had 2a minus b magnitude to find, and they had given me the fact that a dot b should be negative 10, then I start again with 2a minus b magnitude squared being the dot product of the vector with itself. And then when I expand directly, I will get 4a dot a, which is a magnitude squared, minus 4a dot b plus b dot b, which is b magnitude squared. And from here I get 4 into 3 squared, which is 9, minus 4 into negative 10. A dot b is negative 10, plus b magnitude squared, which is simply 4. This would then give 4 times 9, which is 36, plus negative 4 times negative 10, which is 40, plus 4. And we end up with 36 plus 4 is 40, plus 40, 80. So that 2a minus b magnitude will be the square root of 80, which is the same as 16 times 5 gives 4 root 5 units.